Good Friday to you, everybody in Gov 603. Welcome again to week boom 4 in our review of week 3's answer. How you doing? Happy Groundhog Day. The little marmot, little rodent, did not see his shadow. I guess he's not a marmot; he's a groundhog. Did not see his shadow, so that means spring is on the way, or we can only hope. So before we get to the answers, the questions and the answers from week 3, let's get things started off in the right way. Craving wilderness, which I always am. I think I got this cup at the Natural History Museum from Denver, Colorado. And I was coming off of some hike from somewhere. I don't remember where. But anyway, okay. Let's take a look at the questions. A couple of them are, really straightforward. They're just definitions. That is, define it. Question number 1, define and describe mean, median, mode, standard error, variance, and standard deviation. I just need you to commit these definitions to memory. That's just the way it is, okay? The one that maybe, some people get mixed up sometimes is the mean and the median. Note that the mean is obtained by adding up all the numbers and dividing by the number of numbers or the amount of numbers that there are, okay? And I think one of you gave an example of, numbers 1, 2, and 3. The mean is 2 because 1 plus 2 plus 3 equals 6. Divided by 3 is 2. Okay, so this would be literally, in terms of the distribution, right smack in the middle. The median, on the other hand, is obtained by arranging all the numbers from lowest to the highest and finding the number that's about in the middle of the arrangement. And, if you have an even set of numbers, then it's not exactly the middle. If you have an odd set of numbers, then you're going to get a number that's in the middle, okay? The mode, this is the number that appears the most. The standard error indicates how close the sample means is from the true population means. Now, this is really important in statistics because whenever you're dealing with, you're surveying or you're studying a group of people, a sample from a larger group of people, that group, let's say you want to figure out how, like 1 million people are behaving. And so you're researching a group of 1,000. Okay, that group of 1,000, statistically speaking, could be representative of the million, but they're not the million. And there's going to be some variation in the behavior of the 1,000 against the behavior of the 1 million. And that difference, the difference between the mean of the 1,000 and the mean of the 1 million is called the standard error. And as the standard error gets bigger, all right, so when you're looking at statistics, always look at the standard error. And if it's the larger the number gets, the further away the applicability of whatever the researcher concludes from the sample group to the larger group is. All right, so standard error, probably not, maybe some of you have never heard of, but it's an extremely important number in being able to judge the usefulness of a statistic. Okay, the variance, the sample variance measures a dispersion of data from the mean. Okay, I need a handy illustration here. Okay, so we're gonna use our handy pad. All right, let's see. So here we have a bell curve, just like this. Okay, and let's say the bottom represents the time over which something occurs, and then the y-axis over here represents the amount of the occurrence. Doesn't matter what. Cups of coffee consumed over a 24-hour period. All right. And let's say we were trying to calculate how caffeinated the individuals would be. Okay. So those who are close to the intersection of the X and Y axis over here, okay, would be the least caffeinated. Okay. Because this is the amount of caffeine within a span of time. As we get towards the middle, and we're going to draw a line right down the center to represent the mean. Okay, that's like the top of the average. And then the band. that runs down the center on either side of the mean. Okay? That band of people, all right, getting caffeinated over a certain percentage of time. Okay? That is the variance. And the larger that those dotted lines move out from that line, okay, the more they move out, the larger the variance. Now, we don't want them to move out that much. I mean, if it's not a matter of what we want or not, but if we're looking at a big variance from the means, that means that whatever the effect that we're studying, say amount of coffee consumed over time to determine caffeination, is not that significant. The higher up the bell curve, the more pointy it is, the more bang punch at that intersection of time to amount that you have. The flatter and rounder the bell curve, the less impactful of the interaction between those two variables. Does that make sense? Right, and that's why that number is important. Okay. Now, we often express that by saying standard deviation. So how much from the anticipated, the normal mean, that is those two dotted lines right down on both left or right side of the mean. Okay, so the standard deviation is the square root of the variance. All right, so if you took I mean, you know what a square root is, right? It's whatever times itself gives you the number. Okay, so the square root of 4 is what times what equals 4? The square root of 4 is 2. So because 2 times itself is 4. Okay, so we express that statistically. We're concerned with standard deviation, because what we're looking for is, how much out from that mean line. Okay, so how flat is the curve? Okay, so I just need you to memorize these and memorize them in a way that you can understand the concepts and recognize. And if I say, if I give you a question that goes something like, true or false, the standard deviation is the square root of the mode. All right, you're gonna go, no, that's not true. Or if I say, explain, true or false, the standard deviation is the square root of the mode, please explain your answer. And you would say false, because the standard deviation is actually the square root of the variance. Or if I say, what does the standard deviation tell us or represent in a statistical report? You say, well, standard deviation tells us da da da. That's what I mean by being able to articulate an answer. Okay, question number 2. I asked you to describe some of the variables listed in chapter 3 of the Reading the Effect. Remember, I talked about this in my last video. If you watch the video, I will give you a lot of the information that's in the readings, okay, in nice condensed form and well caffeinated form too. Okay, so continuous variable, count variable, ordinal variable, categorical variable, qualitative variable. For our purposes, we're going to focus on 2 major categories: continuous variable, categorical variable, because these other ones are subcategories of these 2 categories. Now, remember, a continuous variable is one that hypothetically has no fixed endpoint on the beginning and the end. Like, how are you feeling? Now, true, when you're surveying somebody, you put together a number scale. A real common one is called a Likert scale, and it always has an odd number. So let's say 5, and you say, respond to the following questions using the following scale. When I wake up in the morning, I feel fantastic. And then the Likert scale would be: number 1, strongly disagree. Number 2, disagree. Number 3, no opinion. Number 4, agree. Number 5, strongly disagree. All right. Now, although you have fixed a categories 1 through 5, the potential for someone to answer is all over the place, because you don't know, how maybe this morning they felt great and the next morning they feel like junk. That's a continuous variable. A categorical variable is a way in which you describe something to fit it absolutely in categories. How old are you? All right. How old are you? And then you would have, say, 1, 2, 3, 4, 5. 10 years old to 20 years old, 20 years old to 30, 30 to 40, 40 to 50, 50 to 60. So you've set it into categories. Someone cannot be, continuous, the old on one day and older on the next. And by the way, just to set the statistical, the research, as well as the biological. That's my undergraduate background. I did a double major. I did a degree in biology and a degree in language and philosophy. But in biology, I did anatomy and physiology, human anatomy and physiology. And there are two sexes, male or female, and there's gender as a thing that supersedes sex is not a thing. Now, you as a researcher, you could ask what someone feels they are. Okay, that's fine. And you would probably use a continuous variable for that. But don't, and this is part of the confusion concerning gender and sex that by some entities it's being perpetrated on purpose. They're placing gender as a categorical variable, as if it's a thing, like male, female, 10, 11, 12, 15 years of age. And it's not a thing. It's an impression. Okay? I mean, there are actual conditions like gender dysphoria. So it's an impression, and it's better described as a categorical variable. And finally, between these two, now remember, this is extremely important, that categorical and continuous variables are not things in and of themselves. Like this pencil is a thing, and this chapstick is a thing, and this pencil is not this chapstick, not vice versa. Categorical and continuous variables are ways through which you can describe the phenomenon. They're ways in which you ascribe, write down the data that studies the phenomenon. So you could study the very same thing and look at it as a categorical variable or look at it as a continuous variable. Okay, very important. You need to keep those two straight. Okay, question number 3. Now we're going to get into some interesting sort of mind stuff. I asked you to watch that short video by Dr. Jordan Peterson, who, to my mind, is probably one of the key thinkers of your age. You should get to know this individual. And if I haven't already, I think I probably did, but hang on a second. Let me again recommend a few works from him to you. His first work, and this is well worth your intellectual investment. It's called Maps of Meaning. I have read and or listened to this book, I think probably 5 or 6 times, and I'm still pulling information out of it. It's essentially, in this book, Dr. Peterson asks and tries to answer the question, how is it that we derive meaning in things? Not things like coffee cups, okay? But things like institutions, cultures, forms of government. I mean, he starts by saying, what got him interested in this was growing up during the Cold War, he was absolutely transfixed and terrified by the idea of total annihilation via thermonuclear war. And he began to wonder, what would be worth holding on to so steadfastly that some culture or cultures would be willing to defend it by destroying themselves and everybody else? Fair question. So he begins by asking, how is it that we derive meaning as thinkers? And then how is it that meaning is expressed? And this is a transcultural, transchronological. That is, he looks at cultures in many different places, in many different times, and he explores those questions. Really, really, technical is not the right word. It's a good thing. All right, but it's worth your time. It's worth your time to chew on it. And then, of course, there's two other books, 12 Rules for Life, An Antidote to Chaos, and then Beyond Order, 12 More Rules. Now, these are not self-help books, but rather he sort of jumps on the other side of the equation and maps a meaning. He's saying, okay, how do we derive meaning, and how can we recognize what that meaning is? And then he jumps onto the other side of the equation saying, okay, if this is the meaning, how do we preserve it, and how do we implement it in a way that's balanced? And essentially, between these two books, he's saying, look, you cannot have too much change, but you cannot have too much the same. There's a back and forth. When there's change for change's sake, this is chaos, and this is destabilizing to human institutions. When there's no change, this is tyranny, which is also destabilizing for human institutions. So you got to have the both. Okay, you got to have order, and you got to have some chaos. So I asked you to watch this video from him, and then I asked you the question of, first explain it, and then how might the Pareto, it's Italian distribution, change the way we think about political, social solutions and problems of poverty and economic advancement. Now, most of you, I was surprised. Most of you said, well, it's the rich just get everything, and so we should have a progressive tax system that takes more from them. I think you missed the point of the phenomenon. But let me read a couple of answers, and some of you had sort of a different take. Maya, let's go to you. Pareto distribution is a fundamental phenomenon that has tremendous implications. Law of economic productivity, based on Price's law and Matthew's principle. A teeny number of people, etc., etc. Okay, I'm just skimming through your answer. Okay, thus the Pareto distribution shows that over time, the smallest number of people win almost everything, while everyone else gradually loses almost everything. In some aspects, it's similar to zero-sum game, where one person gains as another person has lost. Dr. Peterson theorizes that people as they move towards zero, positive feedback loops are established, so they are more likely to hit zero. In other words, they stop doing things. He also theorizes that if people move away from zero, positive feedback loops are established, and they're more likely to move away from zero. That is, they keep doing things. This phenomenon has many implications for political entities and communities who wish to address the problem of poverty and economic advancement. Dr. Peterson's remarks is that it's difficult to do something with nothing, and noted the weird barrier to moving forward in life and a poverty trap where people starting from zero cannot get going, and people who have fallen to zero cannot get started. One policy implication garnered from this paradigm shift might be the redirected and targeted funds, resources, program energies, into strategic intervention mechanisms to prevent people from hitting zero. So it'll be greater efficacy in the higher return on investment. Okay. And that seemed to be, a sort of good answer. It encapsulated where most of you were at. Okay. Yeah, you could draw that as a conclusion, but let me give you another way to look at this. Okay. Since number one, this, as he showed you how the curve developed. Now understand that curve, the tracking of that curve was done through the exercise of a game. And in this game, and I don't remember the exact numbers, but you could use this. You could take 1,000 people and put them in a room, like say an auditorium, and each one has 1,000 $1 bills. Okay. And you say, ready, set, go. They can exchange those dollar bills for anything they want. They can just do it for nothing. They can do it for goods and services, like, hey, I'll give you this necklace if you give me $5 of your bucks. The services, hey, I'll dance around and do something silly if you give me $1. All right. And as the money is exchanged, this curve develops in which about 20% of the room owns something like 80% of the dollars. And then the curve drops off very sharply and goes out to a tail that approaches zero, where most of the people, 80% of the people, own 20% of have possession of 20% of the dollars, and 20% of the people have possession of 80% of the dollars. One of the curious things about the Pareto distribution is why this occurs. And we're not sure, but it is almost a law, like the behavior of gravity. It just seems to work out that way. So yes, while making sure that people don't hit absolute zero, because then psychologically they tend to shut down and go, well, there's no way out of here. Okay. Or when they get over onto the other side of the curve, it's like, oh, well, there's nowhere I can fail here. Okay. However, one of the things that I was kind of looking for that might pop up in your mind is, well, is it just crazy luck? Or how is it that some people end up in the 20% and some end up in the 80%, that is the 20% that's controlling, that ends up with 80% of the $1 bills, and then the 20%, the 80% that ends up with 20% of the $1 bills. How is that? How is that? And what if, in what we did by way of poverty alleviation and economic advancements, we taught those skills, since the Pareto curve is going to operate whenever there's goods and exchanges being exchanged. We taught the skills, and the idea is to move people from the 80% over towards the 20%. Okay? Because one of the suggestions of this phenomenon is you can pump as much money as you want into an economy by way of giveaways. But unless you change the behavior that freezes somebody as they approach zero, or the behavior that tends to land them in that 80% that's approaching zero, unless you address the behavior, you will never make a deep and significant impact on poverty. Because, now stay with me here. The lack of money is the symptom of poverty. It is not now we say, I understand this. We say below the poverty line, we define that by a certain amount of money made. Yeah, I get it. Okay. But here's what I'm suggesting to you that you might take away from this phenomenon, this distribution, is that the lack of money, and especially generationally, is symptomatic of behaviors, and behaviors can be changed. We're highly malleable. Okay. We enjoy something called neuroplasticity, and that is our ability to rewire our own brains. It's a real thing. And if you focus on the skill sets that help people rewire their own brains, say as if they're in the group that approaches zero, not to freeze up, then you can activate the movement of individuals around the Pareto distribution, or at least that's the idea. Okay, but good answers. Question number 4. According to Alan Smith, why should people be interested in statistics? A little bit of a TED talk there for you. Okay, Stefan or Stephanie, Alan Smith stated statistics is a science of us, not uncertainty. Excellent. I couldn't find a better way to put it. Just, puncta in brief. Yeah, because statistics is the study of you and me. It's the study of people, and we're people. Okay, we should be interested in that because we should be interested in one another, how it is we work, what it is that we do that helps us work well and not, and all this sort of things. In other words, statistics is the study of us, of human behavior. And since we're humans and we behave, this is something that should interest us. Okay. All right, everybody. Have a fantastic weekend. All right. Keep working on those part 1s of your paper. I'm going to be out over the weekend, but I will be back on Monday to answer any emails that you might send me. All right, everybody, take care of yourself. I think about you. I pray about you. And come Monday, I will see you again on Canvas. God bless. Bye-bye.